Okay, we're going to graph today, and it's hopefully you've got several 10 by 10s, but also specifically we need some special ones also. Make sure you have one that goes from negative 15 to positive 15 on the y-axis. Let's see. And let's see, and from negative 10 to positive 10 on the x-axis. And then the second graph goes from negative 12 to positive 12 on the y-axis, negative 10 to positive 10 on the x, and the other 6 are what you've been drawn. This is the 10 by 10. So you want one special long one that goes up and down from negative 15 to positive 15, and then the other goes up and down from negative 12 to positive 12. Alright, now that we've got our graphs drawn, make it a little easier for us to move along in the lesson then. So, first of all, we're going to review something that you've done before, and that's slope-intercept form. Slope-intercept form is y equals some number times x plus another number. M and b here just, of course, represent numbers. And hopefully you remember that the number in front of x represents the slope, and b represents the y-intercept, the point where the line crosses the y-axis. Now, there are two important points on every graph. One's called the x-intercept, one's called the y-intercept. There's a short formula right here that represents the way I would memorize that and use it no matter what kind of math you're in. You can always graph a line by looking, if it's in slope-intercept, by looking in front of x to find the slope, by looking at this number to find the y-intercept, and by remembering this formula, which would tell you the x-intercept. When we graph, we're really looking for solutions. Graphing is just a picture way of representing the solutions to an equation. So all the points on the graph are actually solutions to the equation, and the equation part, of course, is the algebra. Of course, the picture part, the graph, would be the geometry part. One of the most, or maybe the most important point on the graph is the x-intercept. As you move on to beyond linear graphs, you're looking at quadratic, cubic, square root, absolute value, piecewise functions, all different kinds of graphs as you go through math. The most important points you're going to look at are the x and y intercepts, particularly the x-intercept. If you can remember this formula that goes with the linear equation, it will help you. Just negative b, the opposite of b over m. To be honest, the part that most people forget is to change the sign of it. If b is negative, the opposite of that would be positive. If b was positive, the opposite of that would be negative. So you just change the sign of b and divide it by m. Now, if things like that are hard for you to memorize, always think of it like this. If I'm finding a point on the x-axis, what's its ordered pair? That number 0. Okay. So if I'm looking for an x-intercept, I can always just plug in 0 for y and solve for x. Alright, what about a point on the y-axis? What's its ordered pair? 0, whatever that number is. So if I'm looking for the y-axis, I can plug in 0 for the x. So think about it this way. Whatever intercept I'm looking for, I can plug in 0 for the other variable and find it pretty easily. Now slope, you can't really do that, but it's pretty easy to look in front of x and find the slope. Alright, let's look at this one. We're going to use the graph that you numbered to 15. Y equal 3x minus 15. We're going to find the three important parts of the graph. We're going to find the slope, the x-intercept, and the y-intercept, and then we're going to graph them, okay? So beside your graph, you're going to write these three things: slope, x-intercept, and y-intercept. Now, slope is a ratio of rise over run. So even when it's a whole number like 3, we've got to have some run. If we don't have any run, we've got a vertical line, right? So the slope, negative 3, can be expressed these two ways. As long as they've got like signs, that's a positive 3. The y-intercept, like I said earlier, b here, that's pretty easy to find too. That's just 0 and then negative 15. That's my y-intercept. My x-intercept is the opposite of b divided by m, and so the opposite of b would be a positive 15 divided by m, which is 3, and 15/3 reduces to 5. And so 5 would be the x-intercept. This is just using that formula that I was talking about earlier, the opposite of b divided by m. Now we have been graphing lines with a single point and a slope, so we can certainly graph a line that has 2 points and a slope. That's just going to give us more information. You can use your slope however many times you want to generate other points. That's what we were talking about yesterday, I think, or maybe the day before. I think it was yesterday. We graphed a line, and Hunter said, well, how'd you get all those other points? Remember I was counting boxes, doing rise over run, and using my slope. We can do however many we want to. As long as my x-intercept and my y-intercept, which I can't do down here at -15, but you can, as long as they are correct, then my line's going to be correct. There's only one line that goes through any two unique points. That's a postulate in geometry. Through any 2 points, there is exactly one unique line. And so no matter how many points or how many times I use my slope, I'm still going to get the same line. So I'm going to go from 5. You can go from whichever one you want to, the -15 or the +5. But we're going to go up 3 and to the right 1 to generate some more points. The more points we have, the more accurate our line will be, because we can use our ruler and make it straight. Then I can go back to 5 and go down 3 and to the left 1, down 3 to the left 1. Alright, generate you a line using the slope. Go from 5, go up 3 and to the right 1 a couple of times, and then go down 3 and to the left 1. Now we're going to have to use a ruler when you start in systems of equations. If your line is not straight, you're not going to be able to tell where two lines intersect each other. If they are not straight, you're going to get the wrong point of intersection. So if you don't have a straight edge, you don't have a ruler or a protractor, make you a redneck ruler. Fold a piece of paper in half, make you a crease, and that's going to be your straight edge. Whatever you have to do, let's make it straight, okay? All lines are straight if you use a ruler. Alright, so we're going to connect our points. You want to extend your line all the way across the coordinate plane, making sure that you touch both intercepts, touching both axes. I can't do that. My graph paper's not numbered 15, but anyway, you guys can. I think actually my point's off instead of my graph here. And that's how simple it is to graph. Instead of having 1 point and a slope, we've got 2 points and a slope. Is that pretty easy? Okay, we're going to practice that a few times today. Alright, look at this graph. Now this one we're going to use the one we numbered 12. We're going to find our 3 important pieces of information. This time my slope is negative. So remember, either the numerator or the denominator will be negative. It again is a whole number, so I have to have a run. I put 1 under there. It's a whole number. My y-intercept is very simple to find. It is this number right here, 12. And my x-intercept is the opposite of b divided by m. B is a positive 12, so the opposite of that is a negative 12. M is -3. Negative 12 divided by -3 is 4. Now remember, this is just a shortcut. If I plugged in 0 for y, and then solve for x like I did in chapter 3 when I was just solving simple equations, I'm going to end up doing the same thing. The opposite of b divided by m, going to get the same answer. Okay, so this just allows you not to have to work it all out. It's just a little shortcut. Uh-oh. Sorry about that. Just a shortcut. Alright, so we're going to look at our graph. Here's the x-intercept. The y-intercept, I don't go up to 12, but you do. So up at 12, put you a point. Now this one is a negative slope. We know. We can anticipate that this graph's going to be falling from left to right. I mean, you're going to start up here at 12, come down to 4. But let's generate some more points with our slope. If I use this slope, I would go down 3 and to the right 1. If I use this slope, I would go up 3 and to the left 1. Going toward that 12 now. The more points you have, the easier it is to use your ruler and connect your dots. Just make that ruler go right straight through the center of them. That's it. That's it. Alright, does anybody have a question? Alright, you guys try this one. Find all 3 points of information and then graph. Alright, Layla, what did you get for the slope? Right. Now remember, we can also write that positive 4 over negative 1, because just to get a negative slope. Alright, what did you get for the x-intercept?
2, 0.
You got what?
2, 0.
2, 0. The opposite of 8 would be negative 8 divided by negative 4. That's true. And then what did you get for the y-intercept? 0, 8. Alright, very good. So we graph 0, 8, 2, 0, and then we can go down 1, 2, 3, 4, and to the right 1, or up 4, and to the left 1. Make sure you've used your slope and found some points on the graph. And let me explain what that does. More times than not, the one piece of information that people miss for some reason, I don't know why it's hard, is the x-intercept. So if you've missed the x-intercept and then you go to your y-intercept and you use that slope, you go down 4 and to the right 1, if you don't end up on the same place on the x-axis, then you found out it's wrong. I mean, if I've got a point way over here and I've got a line going over here, what's wrong? Something. Either my slope was wrong or my x-intercept was wrong. And so by using the slope, you're just double checking and make sure that you knew where the x-intercept was, because honestly, every time I grade these papers, it just seems like we missed this part right here. So if you'll start at the y, and I think I started from the x using my slope, but if you'll start from the y-intercept and then use your slope to find your line, because the y-intercept's easy, right? There it is. You know, who can miss that? There it is, right? So if you go to here and you use your slope to find the line, and you say, hey, wait a minute, I wrote down a -2. Something must be wrong. You go back over here and check. Oh, okay. The opposite of b divided by m. That's right. This point's supposed to be over there. Alright, let's look at this line. This is a special case. This is the equation of a horizontal line. I think we've mentioned that y equals a number is a horizontal line. A horizontal line has a 0 slope. Now think about what the horizontal line looks like. It's saying that no matter what x is, y is 4. I can go over however many I want to, but every time I'm going to go up 4. Every time I'm going to go up 4, because y is 4. And so to graph this line, we go up to the y-axis at 4, and we just draw a line. Alright, so let me ask you a question. What would be the x-intercept? Is it go through 0, 0? There is not one, and so we're going to say none. We're just going, yeah, none. It has no x-intercept. All right, what is its y-intercept? That's right. All right, let me ask you this question. Think about it. What is the only horizontal line that has x-intercepts? And I said that plural. On the x-axis. If I had the horizontal line here, let's say I'm going to make it big. If I had the horizontal line here, what's its x-intercepts? You said it a minute ago. The infinitely many. Infinitely many. We couldn't list them all. And it is the only horizontal line that would even have x-intercepts at all. The rest of them have none. Okay? What would be the equation of this line right here? If y equals a number is a horizontal line, and this one's y equals 4, this one is, yes. That's the only one that has any x-intercepts at all. Alright, so if y equals a number is a horizontal line, then x equals a number must be a vertical line. Okay? And we have talked about it before. There's several special things about a vertical line. We've already talked about a couple of them. We can add the third one now. A vertical line has no slope. Whoops. Has no slope. A vertical line is not a function. Doesn't pass the vertical line test. And it is the only line that's not a function. The third thing we're going to say about a vertical line, they're kind of the rebels of all lines. They break all the rules. The vertical line equation cannot be written sorry about that, in slope-intercept form. I mean, how can you solve for y in an equation that has no y? Right? Makes no sense. And so a vertical line cannot be written in slope-intercept form. It is not a function, and it has no slope. Those are important things to remember from now on about vertical lines, okay? They are a special case. Alright, so this has no slope. Another way to say that is undefined. Alright, now I have to talk about the x-intercept and the y-intercept. We're always beside each graph going to put these three pieces of information beside the graph. That's part of the grade when I'm grading, okay? I would probably count on grade 5 points. 1, 2, 3, and the graph 2 points, okay? So that would be 5 points total in all. Alright, so when you look at x equals -2, that means x is -2. I mean, you can go -2, you can go however many places up you want to, but x is -2, and so the line, a vertical line that goes through, -2 is right there. Okay? And so what would you say is its x-intercept? Where does it cross the x-axis? Yeah, -2. Where does it cross the y-axis? It doesn't. So what is the only vertical line that does have y-intercepts? Yep, right here. Whoops, make that a different color. It's the only one that would have infinitely many y-intercepts. And what's its equation? X equals 0. That has an undefined slope, infinitely many y-intercepts, and an x-intercept at 0. That's just a special case, okay? Alright, you guys, let's look at this one. It has a fraction involved. Let's find the three important parts of that, too, okay? Let's find the slope, the x-intercept, and the y-intercept. See if you can do that with the fraction. Alright, so when we have a fraction involved, of course the slope's not hard. The x-intercept is the opposite of b divided by m. So we use our calculator. So positive 3 divided by 1/2, when you divide by 1/2, it's the same thing as multiplying by 2. So the x-intercept is 6. The y-intercept is given to us at negative 3. So negative 3 and 6. Now, you can tell this line is supposed to be increasing. If I use my slope, up 1 and to the right 2, up 1 to the right 2, down 1 to the left 2. I mean, I've got all kind of points on my graph. Then I just connect the dots. I don't need that. I need a fine point to graph with. Make sure your line extends all the way across the coordinate plane, because in the next chapter, when we start looking at systems of equations and we're looking where lines intersect, if you make two little bitty line segments, they may not, you're going to have to extend them on out so that they can. Alright, find everything you need to know about these. That's just using some fractions as the only difference. Find the slope, the x-intercept, and the y-intercept. Use your fraction button and then we'll go over it together. Alright, the slope is negative 2/3. I can write that two ways. The y-intercept is negative 3/4. Alright, and the x-intercept would be the opposite of b divided by m. If I don't have a calculator, I think, oh, okay, I'm dividing with fractions. That means I multiply by the reciprocal, so which would be 3/2. So I end up with here, what, 9/8, negative 1 1/8. If I have my calculator, I just type it in. Alright, now here's where we get to estimating. And remember that every fraction is not halfway between two integers. Only 1/2 is halfway, right? So when I'm thinking about the y-intercept here, for example, at negative 3/4, here's halfway, and 1/4 is half of that. So I'm mentally breaking up that box into fourths. And so negative 3/4 would be about right here. When I'm looking at the x-intercept, I'm thinking about, okay, there's half, there's 1/4. Break all those up again, I get an 1/8. So an 1/8 is really, really close to 0 there. Or to the, I'm sorry, to negative 1. Oops, I put it in the wrong place, didn't I? Let me try that again. Negative 1 1/8. So I've got half, 1/4, and then half again. So 1/8 is really about right there. Just do that, think about mentally. Where is that really going to be? 0.125 is 1/8. Alright, so now I'm going to go from 3/4. Now I'm not on a line. I'm at 3/4 and I'm going to stay there, even using my slope. I'm going to go up 1, 2, and then to the left 1, 2, 3. Staying about 3/4. Go up 1, 2, to the left 1, 2, 3. Since I'm using a fraction, I'm going to use the one I'm most comfortable with. I guess 3/4 might be easier for most people than 1/8. So then I'll go here and go down 2, and to the right 1, 2, 3, still staying about 3/4. It's hard to make lines like this perfect, because all you've done is estimate where it's going to be. You want to stay as close to it as you can. Use the fraction you're most comfortable with to graph your line. Now, we anticipated this line will be falling from left to right because it has a negative slope, and it does. That kind's probably the most challenging slope-intercept form that there is. Alright, this is the assignment for that. Let y'all write that down. Now, on page 249, it gives you different directions. I want you to graph these just like we've graphed in class. I want you to not follow the directions now, but find the slope, the x-intercept, and the y-intercept just like we've been doing.